Anomaly detection is a way of discovering outliers within a dataset. It is the most common problem that companies face on their data transformation journeys. As more organizations go digital, it is crucial to implement systems that can predict and detect abnormalities so that data can be turned into useful business intelligence. There are various types of data anomalies, often divided into point anomalies, contextual anomalies, and group anomalies. Currently, some of the ways anomalies are detected in the market are distance-based techniques, clustering-based techniques, and rule-based techniques, which each come with their own sets of challenges. Some of these challenges include low anomaly detection recall rate, noise-resilient anomaly detection, and heterogeneous anomaly class. At Apexon, we know data is an invaluable business asset. That is why we've engineered a proprietary method of anomaly detection. EdgeDetect allows you to scan millions of datasets for unusual patterns, intelligently correlate these patterns with their context of occurrence, and highlight outliers with business relevance. Apexon's EdgeDetect proactively detects data anomalies, prevents them, and delivers insights to drive business-critical decisions. It leverages advanced ML capabilities to provide you with insights that can help turn anomalies into business opportunities. Some of the use cases are fraud identification, predictive maintenance, traffic monitoring on websites, and monitoring health data to identify anything unusual, like heart rate data and churn modeling. To demonstrate Apexon's EdgeDetect framework, we will be using the example of identifying the probability of a customer to sign up for term deposit based on certain marketing campaigns by a Portuguese bank. We will call this the term deposit prediction model. Here, the dataset has typical features like age of the customer, job, marital status, housing loan, personal loan, customer contacted, etc. This is the login page of IC4. IC4 is a cloud-native advanced analytics data engineering platform which is integrated with EdgeDetect. Once we log in, we will go to Catalog and register the dataset. Catalog contains the metadata information, so the process is completed, and register the data in AWS. Here, we have pre-registered the dataset, so we can simply search it in the search bar, bank_term, which would display this information. From here, we can go to AI Tools, which has the EdgeDetect component embedded in it. We will click on EdgeDetect, and it will open a new screen where we will have to create a new project. We can give the project name and client name, then submit it. This will create a new project in EdgeDetect. In this project, we will go and create a new iteration by adding the iteration name, selecting the data which we have already pre-registered in the form of a catalog in IC4, and click on Submit. This will create a new iteration in the framework. In the iteration, we have options for Data, Edit, and Delete. We will click on Data to start the iteration, which is our model development process for the datasets that we have pre-registered in IC4. It will show Continuous Variable Summary, Categorical Variable Summary, and Missing Data, percent and count of missing value observation. These types of insights are very useful for the data scientist to get an idea of how to do the feature engineering process of cleansing and handling data to create new features for the model. Now, we will click on Feature Engineering. On the left side of the screen, we have raw data features, and on the right side, we have features for modeling. Here, we will select all the features to create new features. Now, on the last page, we saw that we have some missing values in the data, and most of the values were categorical in nature. So, as per the industry standards, we will replace the missing observations with mode. Here, we will take all the features which have missing values, and then go to Operators and click on Impute Mode. Once done, click on Confirm. This will replace the missing values with mode values, and will append the new data in the existing data. In any kind of machine learning task, we cannot simply go and include all categorical features without converting them numerically. So, we will drag all the categorical features here and apply operators like encoding to convert those categorical features into new features. For example, we have Contact Month, which is the month in which the bank contacted the customer. It will create new features, which is the name of the month. For example, January would be one feature, and February would be another. So, Whenever a customer has been contacted on a particular month, it will apply 1 to that month, and the rest would be 0. This way, we will create this matrix which would then be appended to the existing data. Now, we have new features, and we will be using these for modeling. To see the visualization capabilities of this framework, we will click on Visualize. Select the raw data and select all the features. This will help the data scientist to finalize the features for modeling for better accuracy. Here, we can see that features like duration, age, and job are very important in the dataset and should be included in the model to generate predictions. In our case, predictions will allow us to know the likelihood of a customer going for term deposit because of the marketing campaigns. Similarly, we can see the correlation matrix here by selecting all the numerical variables. Now, coming back to our framework, we would be generating segments from the data. There are 2 ways of generating segments, which our framework supports. One is automatic segmentation technique, and the other is manual segmentation. Auto-segmentation is a machine learning model that generates segments in the data for running any kind of targeted or segmented modeling approach. The manual segmentation approach is when you select a particular feature, and you have the operators which will help you to generate segments by applying certain rules. For this, we will use auto-segmentation and click on Generate. We have generated 4 segments in the data, and as the segment suggested, these are the rules that our machine learning model has found out. We will save these rules by clicking on Confirm. Now, we are finally on our modeling page where we are going to model on the segments that we have found. Here, we will select our target variable of Y, which is historical information of those customers who have signed up for a term deposit, and those customers who haven't signed up. Then, we will select the model. In this case, we will select Logistic Regression and XGBoost. Here, we will run 2 models and show the comparison. We will keep test split percentage as 20, meaning we are keeping 20% of our data aside in the test set for the validation of our model. For the sampling technique, we will choose none as our dataset is not imbalanced. In cases where our datasets are imbalanced, we have the capability to counter that. We have different models to generate synthetic data to balance the dataset. In training sets, we will select segments because we want to run our model on each of the segments and generate predictions. The segmented approach is for scenarios when we want to run target models on each segment because each segment is different, and we have different customers under it, and then on the global data. And we can see different metrics like which segment is performing better, what model accuracy is. Based on that, we can finalize our framework. Our framework supports running multiple iterations and creating multiple projects. It will help us in generating predictions and seeing a benchmark about which iteration is doing well. Then, we can finalize that iteration and deploy it in the customer system. This framework will show the comparison between all the segments and on the global data as well. There will be 5 ROC graphs, Receiver Operating Characteristic Curve, which show the performance of the model ran on each of the 4 segments, and the 5th segment would be the entire data. As you can clearly see, since we selected 2 models, we have 2 lines, and this shows that XGBoost is performing better. ROC is 75% for XGBoost, and for logistic regression, it is 68%. ROC curve is a representation about how well my model can distinguish between my events and non-events, which, in this case, is customers who will be subscribing to the term deposit and customers who will not. Now, in model evaluation, we can see how well my model is performing. We will select Metric ROC and we'll click on Evaluate. This model evaluation will give us a snapshot about which model is performing better in which segments. Here, XGBoost is performing better in most cases. And in this case, the model that runs on the whole data is the best model to be deployed. We will freeze it and go to Rules. Rules is a page which can help data scientists to override the prediction. So, if you are a domain expert, you can go ahead and alter the prediction. You can select the feature and apply the rule by adding certain conditions. Now, coming to the final edge, it is the final view of the Anomaly Detection model. That is the final propensity model we built to find out the likelihood of those customers who would be more likely to subscribe a term deposit for a Portuguese bank. On the left side, there is the confusion metrics, which will show the true positive, true negative, false positives, and false negatives. And the other one is a distribution graph, which shows the distribution of our predictions of those customers and the corresponding data points who would be subscribing to the term deposit on an unseen data, and who wouldn't be subscribing to the term deposit. On the right, you can see the precision, recall, F1 score, and the accuracy of the iteration. This says that our model is 92% accurate for the customers who would be likely to subscribe for the term deposit. On the top right, there is a download button to download the framework, which are the model's objects for each segments, and the inference script, which is deployable script used by the data scientist to scale it for the production environment of the client. Enterprises inundated with millions of datasets rely on high-quality insights to drive strategic business decisions. But data anomalies can lead to erroneous or subpar insights into substantial and crucial pieces of information. These same data anomalies can also present opportunities that were not visible until an abnormality in the pattern was detected. Missing those opportunities can be costly. Apexon's EdgeDetect continuously analyzes information to uncover data anomalies and prevent them automatically based on business-specific needs. EdgeDetect gains new data insights faster and more efficiently, creating significant competitive advantages for data-rich enterprises.